Okay, I'm going to go through problems 26 through 30 on the 2016 exam. So let's look at problem 26. It says the legs of a right triangle are represented by x plus radical 2 and x minus radical 2. The length of the hypotenuse of the right triangle is represented by one of these four expressions. All right, so I'm going to draw a right triangle. And I'm going to have one of the legs. Remember that you have two legs and a hypotenuse on every right triangle. So one of them I'm going to write as x plus radical 2, and the other one as x minus radical 2. Now remember, you have your formula. Anytime you have a right triangle, a squared plus b squared is equal to c squared. Well, in this case, hypotenuse is c. Your hypotenuse always should be the one, the variable on the right-hand side of the equation. Doesn't matter if you call it x, y, or whatever. It should be on the right-hand side of the equation. Okay, now, a little bit more difficult than your basic right triangle problem, but we can do it. So let's go ahead and set it up. All right, so we're going to have x plus radical 2 squared plus x minus radical 2 squared is all equal to whatever you call this. We'll call it c squared. All right, now we have to do some more work. We have to FOIL these out or double distribute, whatever way you want to think about it. It's going to be x plus radical 2 times x plus radical 2. And remember, you have to do this. Remember doing this from last year or some year, hopefully. So you're going to end up with x squared plus x radical 2 plus x radical 2, and then radical 2 times radical 2, remember, is radical 4, which we know to be 2. So that's just going to be plus 2. And I'm going to do the second part, which is x minus radical 2 squared. So x minus radical 2 times x minus radical 2. So that all, when you multiply that all out, you end up with x squared, so I'm going to add this on, plus x squared, minus x radical 2, minus x radical 2, and now this is going to be, it's still going to be positive, because remember, you have a negative and a negative when you do radical 2 times radical 2, they're both negative, so you're still going to end up with 2. So now we have all that. That's a lot of stuff we have here, but a lot of it can be combined. So we have an x squared here, an x squared here, that gives us 2x squared. We have an x radical 2, so we have an x radical 2, x radical 2, and so that gives us 2x radical 2. But if you notice over here, we now have a minus x radical 2 and a minus x radical 2, so that's a negative 2x radical 2. So those are actually all going to cancel out very nicely for us. So we have 2x squared, so we consolidate our x squareds. All we have left are these 2's here and here. So we have 2x squared plus 4. So all of that is equal to c squared. Now remember, to find c, you'd want to take the square root. So the square root of c squared is c, so c is equal to the square root of 2x squared plus 4. And that's answer. Hopefully it's up there. It is. And that is our answer, number 1. We're going to look at problem number 27 now. It says, what are the amplitude and period of the graph represented by the equation y equals negative 3 cos of theta over 3? You could replace this with an x if you had a graphing calculator. You could use theta, really wouldn't matter. Also, you should recognize that when you have x over 3 or theta over 3, that's the same as y is equal to negative 3 cosine of 1/3 of x. So those are the same, which will become important when we talk about the period of the graph, not the amplitude, but the period of the graph. That would be important. So I want you to write down these two formulas, so to speak. Well, one's really not a formula, the amplitude, but the period of a graph is 2 pi over b. So this is b, and b is always going to be the number, the coefficient, or the number next to the angle that's being multiplied by the angle. And amplitude, these two lines going up and down are, they stand for absolute value. So it's the absolute value of A, which A is this value right here, which is in front of the function being multiplied by it. So you can eliminate numbers 1 and 2 because your amplitude can never be negative. It's always going to be positive. All right, so now that leaves us with 3 and 4. Now, the period of a graph is how many times it takes to cycle through all of the values. So if we look here, I want to actually look at a graph before we go over the answer. So I've actually put in y is equal to negative 3 cosine of x over 3. And I'm going to graph it now. And that's what the graph looks like. I'd like to see the cycle on the positive x-axis. So I'm going to increase my my window, or increase my x values. So my x max, I'm actually, instead of 2 pi, I'm going to change it to, let's see, I'm going to change it to 6 pi. And let's see here, and hit graph. And what sometimes is wrong. Let me do that. Let me do it again. And x max cannot be negative if my x min is even lower. That's why I did that. So I want 6 second pi. That should work now. All right. So what we're looking for. All right. So I'm going to drag this out here. And it's stubborn here. I'm going to drag this over here. Look at this graph now. Now, what you're looking for with the period is if the beginning value is here, how long does it take for the graph to cycle through all of those values? And so you go up here, cycling back down. When does it come back down? And we know that that's 6 pi. Now, I kind of already knew that. Now, you could manipulate the graph to find it based on what I had when I first put it up. So when I had my window as, not negative, when I had it as 2 pi, you really couldn't tell what the period was because it never cycled all the way back. So you wanna think about that when you're changing your window if you're dealing with a graphing calculator. But the formula is going to be a foolproof way to always get the period of the graph. So what we're going to do is just plug in. Let me get rid of this graph. And get rid of that. We have been talking about this in class today, so we did talk about it today. So it should be something that's fresh on your mind if you're watching this today. All right, so what you're going to do is plug in for b, your 1/3. So our period is going to be 2 pi divided by 1/3. And 2 pi divided by 1/3 is the same as 2 pi times 3 over 1, which is going to give us 6 pi. So that's going to make our answer number 4. All right, now we're moving on to part 2 questions. This is number 28. I think the next 8 questions, well, it says right here, the next 8 questions are worth 2 points. You receive 2 credits, which means you could do a lot of work and make one little mistake and lose a point. So we have to be careful as we're dealing with them, with these problems. So the first thing I'm going to do is subtract 4. So this, hopefully we remember that means square root. So the square root of 2x plus 1 plus 4 is not in the square root. So what you want to do is get the square root all by itself. Right? So let's go ahead and do that. So we're going to have 2x plus 1 is equal to 4. And, okay, see if you can do the rest. I'll be back in just a second. All right, the next thing you want to do the opposite, or the inverse, rather, or how do you undo a square root? Well, you square it. So you take this, remember square root is the second root, so we're going to raise it to the second power. And we're going to do that to both sides, and that is going to get rid of these square roots. So we're left with 2x plus 1 is equal to 16. Subtract 1, subtract 1, 2x is equal to 15. Divide both sides by 2, and you get x is equal to 15 over 2. That should have been a piece of cake for 2 points. So hopefully they'll have another problem like that, because that is pretty easy, I'd say. Okay, you're asked to factor this completely on number 29. Anytime you see 4 terms, you should think about maybe you have to group. But you want to also look, is there a greatest common factor? In this case, there is no greatest common factor. You have x to the third, x squared, you have an x, but this last term has no x. So x can't be a greatest common factor. And if you look at the coefficients, 1, 3, 2, and 6, no greatest common factor. So what we're going to do is split them up and factor it individually. Factor the first 2 terms and the last 2 terms and see what happens from there. So the first 2 you can pull out in x squared. So we're going to have x squared times x plus 3. And then all of that plus. Now the second part, you can factor out a 2. So we're going to have 2 times x plus 3. Now you have the grouping part. So you group this part, so you have x squared plus 2. And the common factor that they have is x plus 3. Now make sure, once you get to this part, make sure you can't do any more factoring. I'd say because of the fact this is a 2-point problem, that they would not have you do more factoring. If it were a 4-point problem, you might get something like, after you're done grouping, you might get like x squared minus 4 and x plus 3. And then this part here could factor again. But the fact this is a 2-point problem, they didn't have you do that. So your answer is this completely factored. And that's number 29. All right, looking at number 30. It says solve algebraically for the exact value of x. Exact value is code for don't put it in the calculator. Okay? So anytime you see, and they have it in italics for you right here, just to make it nice and obvious, hopefully for you, it means you don't want to have an answer that you get out of the calculator. All right, so remember, you have our log rules. So when you have a situation like this, you can convert this. 8 to the x plus 1 is equal to 16. And from there, couple things you could do. Well, first thing I would think about is changing the base. Now, it'd be nice if one of these was, like, this would be easier if one of these was 4, and then you had an exponent and it equals 16, and you could just change 16 to 4 squared. But can't do that in this case. So what I don't want you to do, so I'm about to write down what some students do, which they should not do. They write 8 squared, because they're thinking 8 squared is the same as 16. Well, 8 squared is equal to 8 times 8, which is not equal to 16. So don't do that. Instead, well, we're going to have to change both of these bases. You could just change one base, but that might get a little too complicated. So let's just change both of them. So we're going to change 8 into 2 to the third, and we're going to change 16 into 2 to the fourth. Now, 2 to the third is just your 8. So we still have to include that exponent. So now we just changed the entire 8 to 2 to the third, but we still have to the x plus 1. So remember, whenever you have a power raised to a power, you have to multiply those two. So you're going to do 3 times x plus 1. Matter of fact, I'm going to do something else first. So I am going to multiply. I'll do that over here. 3 times x plus 1. So that's going to be 3x plus 3. So this is going to be 2 to the 3x plus 3 is equal to 2 to the 4th. Now, we have a good situation. We have the same base. Now we can make the exponents equal. So we'll say 3x plus 3 is equal to 4. Now we can just subtract 3, subtract 3. You have 3x is equal to 1. Divide by 3, divide by 3. You get x is equal to 1/3. If you put that in the calculator, you get 0.33. It is not an exact value. So be careful. 1/3 is an exact value. 0.33 is not. All right, so this is due on Friday, March 11th. If you have any questions or concerns about what I wrote, if you see any mistakes, let me know.